This is the 8th and final section of the sequences and series chapter 3 from the PO2 book. And in this section we look at modelling with series. So there isn't any new content that we need to go through. We're just going to be looking at the question, deciding whether if it's an arithmetic type question or whether it's a geometric type question, and then modelling that by using or writing an equation that shows us what's going on, and then applying those equations to what we know about maybe the sum of a geometric series or the sum of a arithmetic series. So just as a reminder, when we've got arithmetic, then we can find the nth term rule of an arithmetic sequence. So remember that's we write that as un, and what we will have is the first term plus n minus 1 differences. So we'll just remind ourselves that a equals the first term, and this is the same for both arithmetic and geometric. First term, not first tem, whatever that is. First term. D is what we call the common difference. So how much does it go up by in each term from one term to the next, the term to term rule. And R, when we do the geometric, is going to be the common ratio. Okay, so yeah, that will give us the nth term, un equals a plus n minus 1 differences. If we want the sum of n number of terms, and that's going to be n over 2 times by 2a plus n minus 1 d. Now looking at the geometric, so if we want the nth term rule for this one, so if we call that un, that will be the first term a times by the common ratio to the power n minus 1, and the sum of n number of terms is going to be a times 1 minus r to the n over 1 minus r, or if you times the top and the bottom by -1, you'll get a r to the power n minus 1 over r minus 1. It doesn't matter which way around you use it. And the sum to infinity, that will be a over 1 minus r. And remember, this only exists only if r, the modulus of r, is less than 1. So in these questions, decide first of all, is it arithmetic, is it geometric, and then we're going to be applying one or more of these rules. Okay, it says here that Bruce starts a new company. In year 1, his profits will be £20,000. Okay, so this is where he starts. It's probably going to be the value of A. He predicts his profits to increase by £5,000 each year. Okay, so this is probably going to be our common difference D. So that his profits in year 2 are modelled to be 25,000, 30,000, and so on. Makes sense. He predicts this will continue until he reaches annual profits of £100,000. So we're going to have this sequence of profits that starts at 20,000 and then goes to 25,000 and so on. And then at some point it's going to get to 100,000, but it's not going to increase anymore after that. Because when we work out part A, it says calculate his profits for Bruce's business in the first 20 years. Now, you'd be tempted in this part of the question to sort of just say, okay, right, n equals 20, let's just work it out. But you need to be careful, because he could reach that £100,000 profit before the 20 years are up. So the first thing we need to do is to work out how many years it's going to take for his profits to reach £100,000. So if we're actually going to be starting off with a sequence before we do the series and add the values together. So if we look at the sequence, this sequence has a first value A of 20,000. It has a value of D of 5,000. That's how much it's going up in. And we want to work out the number of years it's going to take to get to 100,000. In other words, when is the term UN going to be 100,000? And to do that, we're going to have to use the formula for the nth term rule. So we're actually trying to find n here before we go any further. How many years does it take before he gets to this value? Because after that it's going to stop increasing, and what we don't want to do is keep increasing his profits by 5,000 and get an incorrect answer. So we'll use the formula for the nth term rule. So UN equals A plus n minus 1D. So if we just substitute the values in, we will have 100,000 equals A 20,000 plus n, that's what we're trying to work out, minus 1 times by D, which is 5,000. This is easy enough to solve. So if we take 20,000 away from both sides, that leaves 80,000 equals n minus 1 times by 5,000. Then we'll divide both sides by 5,000, that will give us n minus 1. So 80,000 divided by 5,000 is going to give us 16. So add 1 to both sides, n is 17. Right, so what does this tell us? It means that in the 17th year, Bruce will reach his maximum profits. Which means basically after that, his profit's going to remain the same at 100,000. So now what we're going to do is we're going to work out what's his total profits for the first 17 years. The sum of the first 17. And then we're going to add to that the profits he's going to get in years 18, 19 and 20, which is just going to be 100,000 that we need to add on. It's not going to keep increasing. So we work out his profits for the first 17 years. So here n is 17, so 17 over 2, times by 2a, so 2 times by 20,000, plus n minus 1, so 17 minus 1 times by d, which is 5,000. Okay, so let's work that out and see what we get for his profits in the first 17 years. So if we work that out, we get, let's see, I think that's 1,000,000 and 20,000, 1020. What's the profits? Yeah, little tiny commas there. So that will be his profit in the first 17 years. But remember, in the next 3 years, his profits are going to remain, because it says it here, his profits will remain at 100,000. So to find his profits for all of the 20 years, we need to add what he's going to get in years 18, 19 and 20. So we need to add 3 lots of 100,000 as his profits remain unchanged, giving us a final answer of 1320. So I think this is our millions. Yeah, 1,320,000. Wow, what a wealthy guy. So there we go. So that will be his profit in the first 20 years. Part B, state why one reason it may not be a suitable model. Well, we could say things like it's assuming that his profit's always going to be the same. You know, that may not be the case. I'll just put part B here. B assumes profits always increase by the same amount. So that's unlikely, isn't it, really? But any sensible answer, normally on the mark scheme for questions like this, it says, like, you know, any sensible answer, it will get you the mark for that. It'll be like a 1 mark question. And then we'll move on to part C. Bruce's financial advisor. Does he really need a financial advisor if he's making £1.32 million profit? It says that yearly profits are likely to increase by 5% per annum. Okay, so it's probably a different type of increase here. Using this model, calculate the profits for Bruce's business for the first, or in the first 20 years. Right, so what we should realise in part C is now we've moved on to something which is a geometric series to find that his profits, the value of A remains the same, so he starts off with the same amount. But this time the common ratio, if something's increasing by 5%, then the multiplier, the common ratio is going to be 1.05, so that's our value of R. And N is going to be 20, because it's the sum of 20 profits. So we'll put S20, so it's A times by R to the N minus 1, or 1 minus R to the N. So I'll do 1 minus R to the N. You could do it the other way around, as long as you do the bottom the other way around. So we can have 1 minus R or R minus 1. So you can do it either way. So 1 minus 1.05. Whichever way you do it, you're either going to get a positive divided by a positive or a negative divided by a negative. Now this gives me a value of 661,319.0821. So this is the only time you wouldn't give answers to 3 significant figures when you're talking about money answers. And we need to turn this into pounds and pence. So £661,319 and 8 pence. So it'd be sensible to round your final answer into pence. Okay, a piece of A4 paper is folded in half repeatedly. Okay, the thickness of the paper is 0.5 millimeters. This is probably something we've done ourselves, and maybe folded up a piece of paper, stuck it under the corner of a table to stop it from wobbling. And what we want to do is to work out the thickness of the paper after 4 folds. This is geometric. Each time the thickness doubles, so R equals 2, and we start off with 0.5. Now we could use the formula to do this, but it's actually pretty basic, you know. Before we do any folds, it's 0.5. After 1 fold, it's going to become 1 millimeter. After 2 folds, it will double to 2, and after 3 folds, it will double to 4, and after 3 folds, it will double to 8. Now, if we were going to use the formula, we need to be careful, because there's a difference between the number of folds and the term number. So here, if I write down the values of n, so n is 1 here, 2, 3, 4, 5, but the number of folds is going to be 1, 2, 3, 4. So you need to be careful when you're using the formula, yeah? So actually, n and the number of folds differ by 1. And we need to take care about that, because you could just assume that the number of folds is the same as n when you use our ar to the n minus 1 to find out an nth term. So take care. N is not the number of folds. Yeah, actually n minus 1 is the number of folds. So that might be worth writing down. That might help us with the next bit. So just going to write down n minus 1 equals number of folds. Yeah, so when we do part B, again, R is going to be 2. We're trying to work out the thickness after 20 folds. A is still 0.5. Now, what's n this time? Now, if the number of folds is 20, we're actually trying to find the 21st term. So n would be 21. Yeah, we're using this again here. So the number of folds plus 1 gives you n. You can see that in the what we've got here, number of folds plus 1. So you've got to take care. You could easily just take n for the number of folds. Right, so now we can use the formula. So actually the 21st term, which will be after 20 folds, would be a times r to the power n minus 1. So 21 minus 1. So 0.5 to the power, or 0.5 times by 2 to the power 20. And we get 5 to 4 to 8, 524,288 millimeters in thickness. Let's change this. Let's divide this by 1,000. And what do we get? 524.288 meters. So we're talking about a thickness of paper almost, just over half a kilometre in thickness. 0.524, what's 3 significant figures, kilometres. Maybe that will help me with the next bit, part C. State one reason why this might be an unrealistic model. Okay, well, have you ever tried folding a piece of paper 20 times? I think most people can manage about 7, 8. And I think maybe on some shows where they've picked a massive piece of paper, really thin, they've done like 10, 12 times. You're not going to be able to fold a piece of paper 20 times. Okay, so I'll just put it down. You won't be able to fold a piece of paper 20 times. Yeah, you saw what happened when we assumed we could. We got a thickness of over half a kilometre. It just gets ridiculous. That's not going to happen, folding a piece of paper 20 times. And in fact, if the piece of paper was 1 millimetre thick and we folded it 20 times, then we would have a little stack that would be over a kilometre high. Highly unlikely. Okay, you should now be able to do exercise 3i on pages 84 to 86. So with these questions, decide whether it's arithmetic, I'll just put AP, or geometric. So we can call these things an arithmetic progression or a geometric progression. So with arithmetic, our nth term is going to be a plus n minus 1d. With our geometric, our nth term is going to be a to the ar to the power n minus 1. For our sum of arithmetic series, that will be n over 2 and then 2a plus n minus 1d. And for a geometric series, so I'll just put series here, that's when we add all the terms together. That will be a and r to the power n over minus 1 over r minus 1, or a to the 1 minus r to the n over 1 minus r. And we also have a sum to infinity. Let's correct that too, that should be an n there. And our sum to infinity and beyond will be a over 1 minus r, and that will only exist when the modulus of r is less than 1. Now on this questions, the thing you need to watch out for is n. Yeah, the value of n that you use in the formula may not be the same as the number of years or the number of folds. You saw that in the last one. So do take care. Sometimes you might need to add 1 to n or take away 1 from n. But make sure you work out what n is. Don't assume, oh, 20 years, n is 20. It may not be. You may need to make an adjustment. So just watch out for that when you do these questions.